All right. So NURBS modeling, that's what we are starting with. NURBS meaning non-uniform rational B-splines, just like I've been talking about it. We now want to use them in Maya. Want to use them in Maya. So the NURBS objects are the blue objects, basically the first tab, or in newer versions of Maya, the first and second tab, because in newer versions on the shelf, they separated curves and surfaces into different tabs. So we have curves, then surfaces, but they are all dealing with NURBS, non-uniform rational B-splines, meaning surfaces generated from splines or from paths. They are not singular objects like polygons that have vertices and edges and faces. They are more like generated surfaces. When we did AutoCAD, we used lathe and revolve and all this stuff to make NURBS objects. So you create a path and then you generate a surface from that path. Generally, that's how NURBS are. They are used for organic modeling or organic design. So I'll describe path first, and then we'll go into uh, the surfaces and how we can use a path. So if you want to create a NURBS path or a spline, it's always best to choose the view you want to draw from. Perspective view is never the right view to draw a path from. You always want to draw it from one of these other views, not the perspective view. Because perspective view will not give you accurate placement of the path. So I will use the top view to draw a path if what I'm drawing is going to generate a surface that is flat on the floor or like a road or stuff. I'm going to draw something like a cup or a table or a bottle, something that is elevated. I will be using either the front view or the side view to show the elevation. So there will be no point drawing a cup path in my top view and then coming and trying to rotate it. It does not make any sense. So just always put that in mind that the viewport that you are on or the view window that you are on depends on the object that you are trying to generate. Let me start with that top view. Or yeah, without the top view, I'll explain the curves and then I'll explain the NURBS and then we'll create some shit. Okay. So the first part that we have, not all of these guys are drawing paths. So there's one of these curves that is not here, but I can add it here. If I come under create here, in my curve tools, this one, I see the curve tools that I need, but not all of them are on the shelf now. Like the CV curve is not on my shelf, and one of these curves is in there. So the CV curve is not here. So in Maya, if I want to add a tool to my shelf, this is how you will do it. While you are on that shelf window, go to where the tool is in your menu. So I want to add this. So I hold down Control and Shift and then click on the tool. When I do that, you will see the thing will appear here. Control Shift and click. Now the tool is here. It's on my shelf. So anything I say we should add to a shelf, just make sure you're in that particular shelf. Then look for the thing in the menu. Then Control and Shift while you click it. it will add the thing there. Okay, now I've added this here, or we have added this here. We need to bring it to this part of the line. We don't want it to be here. These are for surfaces. We need to bring this curve to these curves. You can't bring it by dragging it from here. So we will go to this cogwheel here where we have these settings. Then shelf editor. Click on the cogwheel, shelf editor, and we'll have the shelf editor here. So this guy is at the bottom down. Is it here? CV curve tool. I want to move it up. So we use this up arrows, this up or down arrows to move. When you're moving it, just observe it. We want to put it here in this section here. So I'll just keep moving, and as I'm clicking, you can see that it's moving along the line. So just keep moving till it gets to, I want to put it right before or after the square. Another one I want to move it, this base here to this one here. I want to move it forward as well to be the fifth object before the pencil. I want to move this one. So we look for it here, base here, as that. Okay, I want to move it. Okay. So the reason why I did that is so that I can have um, the options. Okay. All right. So, okay, I think there's something else I need to add here. That's not here. Um, there's a tool that will help us close or open curves. We need to add it here. So come under curves menu, your curves menu. That place you see uh let me look for it here. Open and close this one. I want to add it to the shelf. So Control Shift add. Click. Yeah, that's all. And then I'll go and do that. Say shift it to where the curves are from here to that point there. So Control Shift and click. Yeah. Excuse me. So open close right here. All right, I'll put that. Save all shells. For now, no. Anything else need to move, I'll tell you to move. At least I'll show you what to do now. So anything we need that you think will be important, you can now put it on the shelf. The shelf is like supposed to be a place where you keep things you would use over time. So that's like a real shelf. Then the books that you don't use every time, you leave them in the box. So the ones you keep on the shelf are the ones you use consistently. All right, so let's start with the first NURBS path or spline we have. Like these are primitives, the circle and the square. So when you create a circle, it's just a circle. It's a flat circle. So it's a primitive object. Um, it's Yeah, just a basic circle. It doesn't have depth. If you look into the attribute editor, you see it's called a NURB circle. So we have the path information, we have the shape information, that's the things that constrict of the make of the shape. So here we have spans 8, degree 3. Spans is how many divisions the it's like when it comes to polygons now we have those subdivisions and stuff. For NURBS or for splines, you don't have subdivisions. Rather, you have spans or you have isopalms. So, yeah, not pants, palm. No, you are hearing pants. So, isopan. So, then here we have the options to adjust the circle. So this is one thing about the NURB circle. It's or just like every other NURBS object, it's not a singularity. Like it's not this circle is not a circle. It's a spline or a line that is curved into a circle. Because here we see the sweep, meaning that this thing is swept 360 degrees. So if you reduce the sweep, you can see that it's not a circle. It's just a line that is curved and spun around 360 degrees. So this is what makes NURBS modeling very different from polygon modeling. Polygon modeling, it is stitched together, everything is stitched together in mesh. But for NURBS, it's just a spline, one line that is now folded to create a surface. So this primitive circle is not necessarily a circle, it's actually just a line that is spun around. Okay. Now, here, sections here, we have 8, just like we wrote here, the spans, 8. So you can increase the sections or reduce the sections. But I want us to take note of this aspect here, degree. This is cubic. If I reduce the sections now to 3, for instance, you see it's circular, but it's not very edgy per se. It's still got some grace there. But if I change from cubic to linear, this is what I get. Because when it's cubic, cubic means no matter how limited the sections are or the spans are, try to still maintain a curved surface. So that's cubic. But linear will be act as if it's a polygon. So if it has 3 sides, give it 3 sides. If it has 4 sides, give it 4 sides. If it has 5 sides. So on linear, if I go and increase the size, I need to get very high to get a circular form for linear creations. Okay, so let me leave this at 8 where it was. So at 8 for linear, this is what it look like, but for cubic, it will look very circular. So this can come in handy, especially when we are creating our NURBS tables and all the rest. Okay. So understand that. Now we have the square, the NURBS square or the NURBS rectangle, or let's say the NURBS square. It doesn't have many tabs, it's just itself like that. Notice it just has one. Now you'll be thinking, why? Why does it have just this? It doesn't have those other plenty tabs that this guy has. It just has one tab. Now this is a knob square, right? But each of them are different lines. The way knob squares work is it's not a complete object. It is 4 lines coming together that are not even stitched together. So that's problem. So if you want to generate a surface from this, it will be very, very troublesome unless you find a way to stitch these lines together. And there are two ways to stitch it. One by using a stitch, a fillet stitch, or the second one is by using a code, a node code that will break it off and connect it to another. So that's a very different one. I will show that one when we are learning how to rig. So, so this is the NURBS square. So now that I have one line selected, I have a lot of tabs. But when it came in as a singularity, I just had one tab because generally it's not one single object. It's four objects coming together to play. So you can increase the spans on one. It just increase how many divisions are on the line. You can increase the length, the breadth like this. So, but it's just note that this object is not one singularity. So don't ever use it to make something. Okay, because it's square, want to now extrude something from it. It will not give you a good result. Right. Then we have this curves. It actually stops here. All these ones are not curves, they are curve editing tools. But the curve stops somewhere here. The first curve is called a CV curve or a control vertex curve. This is how CV curves work. They work like, remember the curve pen tool in Illustrator that naturally creates curves as you are clicking it. That's how this CV curve works. So when you click a point and you click a point, it looks normal. But when you click the third point, then you click the fourth point, you now start noticing an issue there. The line is not, the curve is no longer following the line. It's following its own curvature and making curves from there. Okay. So Maya, when you finish creating your curves, you just click OK. I'll press enter on your keyboard to end the curve. So this is why this curve is called a CV curve, or why most curves are called CV curves. Control vertices. The vertices do not reside on the curve, they reside outside of the curve. So when you are controlling it, you control those vertices on the outside. You don't touch the curve itself. You touch the vertices. So it's more like using a string to control the puppet. So that's why they are called control vertices. Then the direction of your curves. The first point will always be a square like this. Then the second point will be this U. And then you have point, 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 point. So basically, that if you want to reverse the direction of the curve, this square will now come here and the U like that. And it will now follow those progressions generally. These are control vertex curves. And thing about curves is, as this one is, I clicked, it has four spans. I clicked 1, 2, okay, 1, 2, 3, 4, 5, 6, I think 7. Let me think 7. 1, 2, 3, 4, 5, 6, 7. Yes, 7. So I click 7 points here. So I have four spans, 3 degrees for my curve. If I want to make the curve smoother, there's an option to smoothen or rebuild the curve so that it gets a smoother form. And we find that under the curves menu. Like now, if I go to curves, I have a rebuild option here. You have it here as well in your shelf. So if I click on this square here, I can say, okay, now the spans are 4. I want to rebuild it to have something like 12 spans, try to be smoother. So I just increase the number here to 12. Okay. Once I rebuild, it smoothens out those sharp edges, and we see the number here changes to 12. Okay. So All right. So this is how to rebuild curves. Now, if you want to close your curve, your points, like from here to here, in newer versions, though, when you click and come back here, it might close. But you want to close, you click on this guy here, this open close option that we added, and it will close the curve for you. If you want to open it again, you click on it to open the curve. Generally, because the way Maya is designed curves to work, you can't actually join 2 points by clicking on them. So to join 2 points, you tell the software to do it to wedge them or weld them together. All right, so this is a control vertex curves. Now the next curve is an EP curve. That is, and this edit point curve. EP, edit point curve. When creating it, it creates different from a CV curve, but after creation, it becomes a CV curve. That's the weirdest part of it. So like this one, if I'm clicking the same way I did with the CV curve, as I'm clicking, the curve is curving around the points. Wherever the points go, that's how the curve is following, right? But after drawing, and you right click and go to the control vertices, you will see that the points are actually far away. You didn't actually create them here. So it just created them here while you were drawing. So those are the differences. So in creation, they become control vertices. I mean editable points, but in editing, you can do control vertices. Now, if you want to edit the vertices, the control editable points, so when you right click, you switch to edit points. And want to switch to control vertices, you switch to the control vertices. Okay. So are we cool? Yeah. Jason? Ah, yes, sir. Oh, hope it's money you're collecting. Hope it's money you're collecting. You wish. Okay. So remember that right click thing, they want to access any of the modes for editing anything. Just right click and you can go into any of the modes to edit them. Right. See me, I want to press V. Thinking I thought that was in Photoshop. Now, this other points here, this one, and the same thing, you can close and open it, just like the other one. The next one is the Bezier curve. We already know how this one is used. Yes, Bezier. He's thinking of Bezier. So Bezier curves is just the same way we've always used them. It's like the pen tool. You click to make straight lines. You click and drag to make a curve that goes in different directions. So that's Bezier curves. Now, for Bezier curves, you can actually click and come back. But let me just press enter. The way these ones work, control vertices appear on the line. Because Bezier curves are neither CV or EP curves. They are typical curves that exist, like how the pencil works. So because it's a multifunctional curve, the CVs or the control vertices reside on the line. They don't reside outside of the line like these other ones residing outside of the line or the spline. They reside on the spline themselves so that you can use the handles That's all these Bezier handles and gets the adjustments that you need. So that's just how Bezier curves work. They are quite different from this. Second of all, just as we can rebuild these curves, we can't rebuild the Bezier curves. Like if you go to try to rebuild it, to give you an error that tells you this is not a CV curve. So it can't rebuild them like this ones because Bezier curves are intentionally made. When you click and dragged or you clicked and passed, you did it intentionally. For CV curves, because the points are not really on the curves, you can rebuild the paths because they don't necessarily affect the points. They are not residing on the curve. These ones reside on the curve, so you can't rebuild them. Right? It'd be easier if they were outside of the curves themselves. Right? So this one we're already used to. This one is a free-form pen, just like a normal pencil to a pencil. Yeah, just or brush to just draw around. Then this last one here is a 3 point circular arc where you create the first point, a second point, and a third point to create an arc. 3 points, 3 point shots. He used to play when he was alive. Where? That's listen. That's just it. Yeah. But there's nothing peaceful about this. Nothing peaceful about that sign. Yeah, yeah. Yeah, they thought it was peace. They were to be fine, but it wasn't. Mm. The symbol means something else, but it's generally used as peace symbol. Just like the emojis and every other symbol that is existing now, they are the interpretations we are using now are cover-ups for the real interpretations. Yeah, but do you know where they originated from? What they actually meant? Mhm. Right. Uh, is there a question? I'm not listening. Okay, question I want to ask you. This one is just direct drawing. I'm not trying to show you how to draw, and then how to close your drawings. Uh, is your favorite up to when you have to now adjust the editable points? Because when you go to the control vertices, you have a lot there. So it's not much of a favorite. Okay, so these guys, that's those guys, and basically they are used to create um object. Come on, stop turning off and on. Now, the direction of your curve flow is important when you are creating an object or a surface. It's actually important, the direction of your curves, because if they are facing the wrong direction, the objects you create backwards or wrongly. I showed the example in 3ds Max and in AutoCAD. When your curves are arranged in the wrong direction and you generate a surface, it's like the surface goes on the inside out. You have that black shade, you now have to go and reverse it again and change it back. So it's always intentional that you note where the direction of your curve is, and that's by identifying where your first point was, and where the last point is. Because sometimes you might have a situation where you want to connect two curves, and I have this curve starting like this, okay, and I switch back. Now, if you want to switch back to the format, you just press G. And now, instead of me starting from here, I can start from here like this. Now, by look, these two curves are just curves. But the software recognizes that if I right click on this guy, this is the first point. If I right click on this guy, this is its own first point. So if I try to generate a surface that connects here and here together, it will act weirdly because they are not facing the same direction. So you have to be very careful of understanding where the direction of your curves are going. So that if you need to reverse this curve, then you can select the curve and reverse it. But don't do like want to use like a bi-rail. There's one of the NURBS objects that's called a bi-rail that connects two parts together. You want to do a bi-rail, it's to give you a very wrong direction. So you can use your curves and reverse the direction. So if you want to, if you are somebody that knows you will make a lot of that kind of mistake of making curves wrongly, you can add this reverse direction to your shelf so that it's there for you. Otherwise, just reverse direction. So it doesn't change, flip the curve, it just changes its direction. So now the first point is no longer here, it's now here. You notice the square? Will I undo it? Let me undo this. I've undone the reverse. So now, where's the square? This is it, right? You always, if you can't see the square, always look for U. U tells you the second point. So square and U, right? So that means this is first, this is second. Then we have this. So just like this one, this is first, this is second. Very good. So now I want to reverse the direction of this curve. It's not going to flip the curve like rotate and turn 180 degrees. It's going to reverse the direction of where the first point should be. So just come to curves, reverse direction. Now when you right click, U is no longer here. U is here right now. So that means it has reversed to start from here as this is the beginning and that's the end. So anytime you're having challenges, sometimes when you're dealing with NURBS objects, always check the direction of your curves. It will help your design because if not, you will have issues in that design conflict. All right, that's cool, right? It's good. So let's see very quickly these other guys. These other ones, these are NURBS primitives. These guys here, NURBS primitives. We have the knob sphere, we have the cube, we have the cone or cylinder, sorry, and then we have the cone. Yep, and we have this guy called the planar, and then we have the torus. Good. Now these guys look, they look normal, they look okay, but let me match them with their counterparts. The sphere in polygons, we have the cube, we have the cylinder, we have the cone, we have the plane, the other one is called planar, and we have the torus. All right. So let's see what makes them different. Looking like this, is there any difference between the two of them? Which one is polygon? Okay, it's just that one. Okay, wait. Let me do something. Try to be a little bit more similar. Let me make it like this. Okay, right. So that it looks a little bit more. There's not a black spot. Mm, okay. So I'll come to the cylinder. Okay, so if looking at them minus this guy, is there there's no difference. They look the same. So let's start with the sphere. Let's start with the sphere first. So this is a polygon sphere and this is a NURBS sphere. So by look, they don't look any different. Actually, let me change it to wireframe on shaded so that we can see the differences between them so we understand what is going on. Now, for the polygon sphere, it's I need at least 20 subdivisions on the axis and the height to get it to be round, spherical. The less the subdivisions, the less round it gets. Okay, can make those Chinese or Japanese lamps with this guy. So can do that. So let's say I do 6 by 6. This is the shape I get. Very unspherical. For this guy, the knob sphere, I don't see 20 sections or spans. I just see 8 and 4. So if I let me make this guy 8 and 4. So 8 here and 4 here. So this is what this guy should be looking like with the same setting, but it's not the same. Okay. So the only time this will change to this is if I change it from cubic to linear. Then it now starts behaving like this. Okay, but as far as it's cubic, it is forced to always be round, kind of. So even if I reduce the sections from 8, it is still round. Even at 3, it's still round. Same thing with this. So it's not how many spans that matters. It just is round. Why is it round generally? Because the way NURBS surfaces work, remember how this granite used to buy on the road, where the woman will carry one paper and fold it into a cone and put it around. So you see a cone, but it was actually a flat plane. That is how NURBS surfaces are. They're actually a flat plane that are folded from something. So that's why they have a sweep value. So you can unsweep it. You have a sweep value. You can open it up because it's just folded. It's just wrapped around itself. That's how NURBS are. Polygons are not wrapped around, so you can't sweep. Every part is stitched together. So that's why by default, polygons are the only objects that qualify to be called mesh. Because a mesh is any object that is a combination of vertices stitched together to form edges. Those edges are stitched together to form faces. Then those faces are stitched together to form that object. So there are a lot of faces stitched together and now form a mesh. So, but a NURBS object is just one conglomerate, just one object that is rounded up. But that's how it, so it therefore the modeling structure or process in this is always different. Because if I right click on my polygon, I have faces. I can select a face. I can pull out a face. I can push in a face. I can select vertices, select a vertex, move like that. I can select edges. I can select the singular edges and move. Or when I come here, there's no edge. There is no face. What we have is isochron, control vertex, surface patch, surface point, hole. There's no face. That means I can't select a face. So I can't extrude just this small part. out when it comes to NURBS objects. There's no extrusion for that point. If I say, okay, control vertices don't reside on the splines or the shape, but I can pull them out. But if you look at the way the object is moving, it's very rubbery, like rubber. It's not rigid when it pulls it out. So that's why NURBS objects are used to create organic design because it's smoother, it's more organic, it's not rigid compared to the polygons, right? Okay, so let's look at the cubes. This is a polygon cube. Every part of it is connected together. It's just one whole object with 6 sides. Then you can add divisions to each side based on height or width. So it's just one object. It's not separated. Let's see the NURBS cube. The NURBS cube, just like the lines, are not connected. Everything is separated because the cube is a scam. It's just 6 flat surfaces that came together to form the cube, but then they are not even stitched together. So modeling with that will become a problem unless you stitch it. And even after you stitch it, it won't be as rigid as a polygon. It will be moving as soft as how this um, sphere was moving. It won't be moving hard. It will be moving and pulling other parts of it along like rubber. So if I want to create something rigid, using a NURBS cube will not be my instinct unless it's organic. So let's see the same thing with the torus. The torus for the polygon is not swept. It's just one object. So the only thing I can do is twists. I can change the amount of subdivisions. So if I twist it, it's easier to see. I can change the radius, but that's the best I can do. But for the NURBS, I can sweep to open it up. It creates like a pipe section. So I can increase the radius. If I turn it to linear, it becomes rigid, just like this again, same way. Then you can increase the number of spans. Then all this minor sweep, that's the inside, this one here, create this kind of shape. So you can do this kind of design easily with a NURBS object. With a polygon object, I will have to select all these points here and delete them. So all that exists is that top one inside. So for organic modeling, NURBS are always the best. But for rigid modeling, box modeling, use polygons. Let's see cylinder now. This is the one we've created first. It didn't have a covering on top, right? Now let's see the second one I created that had a covering on top. This is the second one that has a covering on top. Now look at the funny part. See, I selected this guy and it moved. Good. Check this one. I can select this other one and move it. So it's actually not the same object. The way NURBS work, it's supposed to be a flat object that is folded. So if you see a cover on top, it is not part of this fold. It is another object added on top of it because it's just folded there. So using a cylinder here, this kind of cylinder, you have to put in mind that this top is not the same with the body. You have to do different things to them simply. Okay. So the only guys that look a little bit similar are these two guys, the planes, because this is actually how a NURBS is. It's just this guy, this rectangle that is folded to form all these other objects. Same, this one is subdivided. The cone is the same thing. The cone, it has a sweep. It's not a regular cone. The polygon cone is the one that is a regular cone that doesn't have a sweep, but it has caps on the top. You can make a round cap to give it this bottom section here and divide it and all these other options. But we don't have that option when it comes to NURBS. We just have the same spans, the same sections, the same degree, and then you have the sweep value. So when working with NURBS primitives, it's fair to note that it's not a singular object. It's I mean it's not, yeah, it's not a singular stitched object, but everything is just one flat plane that is folded to create those objects. Is that cool? We understand that small, right? Okay.
Basically, all the nerves.
All the nerves. I love it. Don't make them look bad. They have their strengths though, but not at this point. Okay, so let's see nerves modeling using revolve. We have the loft, we have the planar, we have extrude, we have the birail. These five guys. So revolve, we already know how revolve works. It creates like a table. Let me use this guy. So we take, I'll use the pen, the Bezier tool. So click, click here, click up, click here and drag, uh, click here, click, 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 click like this, click like this. Uh, click this, click here. I'm using the grid and enter. So I can go to control rotate so I can adjust this guy to be straight now. All right, and okay. So we already know this. We already know this technique. This is what happens when you eat too much beans in the morning. What is going on with Mike now? So one of the techniques we have here, once you've created the shape, just revolve it and creates your table for you. So we already have know this technique. We did it in 3ds Max. Uh, so you draw your table here. So this is a benefit here. 3ds Max, once you've done this, the path kind of exists with the shape. But here you can take this shape out and leave the path and create something else. So check this out. I can create two shapes, right? Then I'll decide, okay, this one is cubic. I can decide that I'll make this one linear and reduce the amount of sides so that it looks a little bit different from the first one. Okay, this one can be like sides too. Then this one is the main table. So same design, same profile, but after creation, I converted one to be linear, reduced the spans, and it gave me a different table size. I can create another one and change it to linear, make it have 6 sides instead, scale it down and make it longer like this to give me a different design entirely. So I have 3 tables from the same profile. That was very quick to do, right? You didn't have to start drawing another profile again. So I can create as many tables as possible with that profile. Now, 3ds Max, once you create one profile, you create only one table. It doesn't leave the profile for you. Once you convert it, the profile and the created object become one object. So, but this one, the profile remains. Now, this is the thing you need to take note of. Once you are done with your profile, you need to hide it from the scene. The shortcut to hide the same way, just press H. Because if you don't hide it, this is what will happen. If you remove the profile, you, to adjust the, because the software is reading the data of where the profile was for all the other guys. So normally what I usually do in a production setup like this, where if I use one profile for multiple objects, I now create a group and hide that group. So all my profiles are kept in that group. So if I press H now, that's as hidden the profile. I can't access it again unless I click on it from here. So these guys are now free to be used for my multiple designs. So I like Maya for this purpose of using one profile to create multiple objects and multiple designs of an object. So it's very clean. All right, so that's table. You can create bottle the same way you create a bottle, and then you do multiple profiles as well. You can create multiple types of bottles, same size or different sizes, different shapes, but from one profile. Mm. No, you're not duplicating. If you duplicate, it's just the same thing you're doing now. Mm. Mm. But this one, just create from the profile, create again, change the attributes of that one, create another one, change the attributes of that one. So one of the keys of modeling is, yeah, which for the table. I said the this thing, the Bezier tool, the one that's like pen, so that I can make straight lines and curved lines easily. So if there's a reason when I have to use a reference, like I want to make this bottle, for instance, or a bottle in my scene, it's always preferable in 3D that you use a reference image. To add a reference image into Maya is is quite easy. You don't need to create a in 3ds Max to add the reference, you need to have the plane first, and then you attach the reference to the plane. Preferably use a plane that is the same size of the reference you're bringing in, that you have accurate drawing. But here you just add the reference image to the camera that you are viewing. So probably front view, side view, top view, or whatever view you have. So this icon here, the fifth icon, 1, 2, 3, 4, 5, this one here, or if you come to this view, under view, image plane, you can import image or remove it. So, but it's the same way. So you can click this. Let's say I want to import a file. Let me come to where my files are. Um, MSP stuff. That should have a picture of a bottle somewhere. Did I do Coke? I think that's the closest. Yeah. No, that prime bottle I is this guy that was holding the bottle and I drew it from looking at it. Chinko. Let me use this Aquafina. Aquafina. Hmm. All right. So this is my profile. So I can now use this guy as a profile. I can take my pencil or let's say my Bezier tool, then come over here. So let me make it. Let's make it here. Then here, click here. Okay. So not very straight. So just something. Yep. So let me adjust it. Now my control vertices. Okay, so I can now just orbit this guy first to create the bottle. I can hide this guy from this view. Okay, so I have the first bottle. Sorry, I have my first Aquafina bottle. Then from this guy, I can create another revolve. This time I can make this one more linear. Thin. No, it's not thin. Nah, no, well stretched. Okay, so now where am I? Okay, so this guy, I can make it linear and reduce the part side looks more like what they call this yogurt bottle that looks a little bit square. What's the name of that yogurt? It looks something squarish like this. And I can make it just a tad fatter and shorter to give this a different uh, feel. Give it a different feel. So I just have three. Let me hide this guy. So I can now have three bottles, all of the same from the same profile, but all looking different. And I can put that in my scene. So that's the beauty of using these guys. So that's how Revolve is. It's typical way we've been using it. Um, Typical way we've been using Revolve everywhere else. So the next one that we have here is the loft. And the loft is, well, a lot easier than using it in 3ds Max, you don't have to be doing a percentage and be changing every time. The same way you use it in say in Photoshop, in AutoCAD. So you have one shape, you create another shape, or probably at this level, create third shape, make that one kind of larger, create a fourth shape, that one up, create a fifth, create a sixth. This and this your gear, your gear, with your seventh. Thank God this is on that record. Mike's property. Now you're denying it. Okay, so now I'm going to build a loft by connecting all these circles together. The direction, it matters when building lofts. You have to select them in order. So I will do something first. I'll select them in the correct order, up to down. I mean down to up, because that's how it's created. I'll also now select them up to down, because here this is the first, second, third, and on like that. So I'll select the first, hold shift, select the last one, so that it goes that way, and loft this. Loft will just create a singular object. Shisha, you like select. So what is the difference in what I did? I did the same process. I selected the circles and I clicked loft. One came out gray, one came out black. So why did the one come out black? There's something I explained earlier. But why did it come out black? Okay, let me do it again. See, this was the first one I created. This is the last one created. So from my outliner, I can see them from their numbers 1, 2, 3, 4, 5, 6, 7, 8, right? So I select the first one, select the last one last, then loft it. It comes out normal because that is the correct direction of the curve. Now, if I select 8 first, that is, I'm going down and select the first one. It's still selected in an order, but that was not the direction, because if you look at my gizmo, the Y is pointing that way. That is the direction. So, but selecting them this way, the Y is still pointing that way. So the software thinks, oh, I'm doing a reverse of what is happening. So when I click on loft, to create the reverse of that, kind of flipping it, is the inside now is the one that is gray. So this supposed to be the back. Yeah, the inside out. This supposed to be back. This then the texture. So if I add a texture to this object now, the texture will appear inside, not here. So it's going to be in the wrong direction. So that's why I was saying that thing about when you're working with splines and this, you have to take note of the direction of the spline to avoid creating an object that is reversed. Okay. But in case you do this and, like I said, it was mistake, yeah, error, there's always that option to do what? Reverse direction. Now, this is not, is this a curve? This is not a curve, right? It's a surface. So if I'm doing reverse direction, it's not the one on curves I will look for. It's the one on that surfaces. Because this is a surface. Is if I want to change the direction of the curve that I will go to curve. But for surfaces, I go to surfaces, I can reverse direction of the surface so that it comes back to look like the previous one. So in case you have that issue, yes. But there are times your issue can be very complex. And the reverse, maybe you picked like this, yeah, from here, or you pick like this one, let me do like this. You pick one, two, three, you now came to four. Oh, you now skipped. You come and pick five, then go six, seven, eight. It looks like you picked everything correctly. But the software knows that one went up and came back down and went up again. So, okay. So when you move, you have a different kind of design entirely. It goes up, it goes inside, then comes out again. So, so it creates a weird kind of design entirely. So this is the good thing about why Maya separated theirs is all these three guys were created from this guy. Are you paying attention to this? So let me change this guy to linear so that it looks different. Okay. So that one no problem. So so look at this now. I want to adjust them, but I coming to adjust this one first and then coming to adjust this one and then coming to, it will become a problem. So because they are all connected to this guy, remember what happened with the table now. When you move the table, everything goes. So you can just do this. Mm. You can just adjust the design from here. No, if I come on, it looks like something else. So you can change. So you can just change your design by changing the profile. If you shift this profile away, you guys don't have it. Okay. So you can just play around with the profiles and you adjust everything that was connected to that profile because Maya record the data of all this is reading from here. So anything you do here affects the originals or the instances basically that you have made from them. So that's why you need to hide them. And you don't do control spoil and be wondering what happened later. So like this ones now, because they're all connected together, I want to group them first before I hide them so that I remember that they're all together. So control G first and then I hide it. So now I have different shapes. This could be some interesting kind of gas lamps for you. So, mostly you squeeze, bend, grab, pull, pinch, do with the shape to give it this the shape. They are digital. Brushing, definitely. Yes, they use the same process. All of the softwares for sculpting, all of them work the same way. Mm. It, yeah, Blender is primarily a sculpting software. It's not a polygon modeling software. or Maya sculpts as well. Next to ZBrush, ZBrush is still, uh, to me, best sculpting software. Then followed by Maya, because the tools Maya has for sculpting are similar to the tools in ZBrush, which don't exist in every other software. So Cinema 42 uses sculpting, Blender uses sculpting, 3ds Max uses sculpting, but there are some brushes that Maya has that they don't have, that ZBrush has. So that were generally most people, once they enter into Maya and ZBrush, nothing else exists. All right. So that is Lofts. Similarly, just build a profile, different profiles, and then connect the objects together. The one that we call a sweep in, uh, um, the sweep that we used in AutoCAD and okay, we did it in 3ds Max. In Maya here is called extrude. So more like you draw a path. So let me use the CV curve to draw a path. So draw a path and then draw a circle. Probably rotate the circle around, let me rotate the circle around this, definitely something like that. Okay. So in order to sweep in Maya, or to do any generated motion, um, effect or any generation like that, the first thing you always have to do is create a statement in your mind. Like right now, I want to sweep this circle around this path, right? So the order of that statement made, sweeping the circle along this path, that is the order in which you select the objects. So you select the circle first, then you select the path, and then Maya doesn't have sweep, it has extrude. It's the same thing. So just click extrude, and then it will sweep the object along the path. Now, this is getting confused. So now watch this. It's created my path, right? But it's not following my path, because in the options here, I have options to be fixed to the path or not. So this is fixed to path, which will fix to path. And then we have closest endpoint of path, component pivot, then we have center of bounding box. So depending on how your path and your profile was, you will choose one of these three. Based on the way I designed this, component pivot is the best one to adapt to my path. Good. So that's how you create the sweep. So if, for instance, this guy, I used something, I made him linear instead of cubic, and maybe reduce him to 4. You notice that it's affecting my pipe, right? So I want it to be 4, but I want to rotate this to be straight like rectangle, and then I want to scale this guy based on world. I want to scale it on this axis. So I can make like a road network with it. So you just use that to make a road path. Then any object I want to move along the road, I will attach it to that path and it will move along that path. Wednesday. So we get the drift, right? It's very easy. So I know we built a house in 3ds Max, or we didn't build. We used that my structure, and then you're now building things to put inside, create stuff. Yeah, you can. If you've not completed your items, you actually use Maya to build items very quickly. Or you could actually bring in that file here and build in your items here. Either way, when you are creating your camera walkthrough, we can either use Maya or 3ds Max. The the secret is uh, the camera walkthrough will not write on the exported from 3ds Max or exported in Maya. It will just export something. So you just whatever you want to do, 3ds Max or Maya. Once you get that project working, just make sure it's submitted in the right way for 3ds Max or for Maya, regardless of what software it is. Even if you use Blender, when you finish using, submit it as a 3ds Max file project or as a Maya project. Okay. That's why I'm teaching and based on the course outline, most of the things that has to do with character animation is taught in Maya, because in Maya, when it comes to designing all these characters and the rest, it has better tools for that, or geared for that, easier tools to manipulate, easier techniques. So you can use Maya to achieve a lot from those stuff. So try to let me rebuild this curve. Okay, so it's smoother. It was not looking very smooth. All right, it's better now. All right. So are there any questions about nerves? There are some two of them that I've not talked about in nerves. I don't really need to, because frankly speaking, they are not always used except the birail. Is there anything that you find complex or is similar now, because of we've done things like this before, right? Okay. All right. So let me show you one fun thing, but we'll do it later in the course. But I don't want to show you. Let me use this bottle, this yogurt bottle, or this one. It's something we will do in the course. It's called that mash. I just want to mash, MASH. Mash is a motion graphics uh, technology instilled into Maya. Like I said, it's like Cinema 4D, Blender, and Maya came together and created a weird baby, and that baby was is now Mash. So Maya decided to be the mother of the baby. Cinema 4D is a software that is predestined to be the motion graphics software. That's what it was created for. So Blender is a free tool software that also can do a lot of good motion graphics design. Maya also has its own, but then Mash came in, incorporating the three of them together. If I needed to create a grid of bottles or a crate of these bottles now, like let's say inside a crate, it's easy for me to use Mash. I can use normal create, duplicate, and just make multiple and manually put them inside. But see this mash here, this shelf here, mash. Just like the bottle I come to mash here. I can just create a mash network this by clicking this guy, and it will. Oh, okay. Sorry, this is not. Let me convert him first of all. I want to convert him to polygon. Right. So I create a mesh. I've done that now. Where is the polygon? Oh, all right. There you are. I have no idea. Mm. Why don't you use the restroom? Why? Yeah, sometimes it can help, or sometimes no. Um, 5 is okay. A crate of, but okay, they're usually 4 by 4, right? Yeah. It's okay, three in 4 places, like to form 12. Yeah, I think it's 3 by 4. Yeah, it's 3 by 4. 3 by 4. So I could make my no, as in I'm trying to show how I can make multiple clones with this tool and put them in a crate or put them in crates themselves. So no, just in a crate of uh, just to separate them. One, two, three, four, five. Usually it's always four. Okay. Because if you click and drag, you can't do it. You can't do all this. You can't separate them. They, they just thought you were in the bathroom. We just thought. We did not say he is actually there. Okay. Why must you touch somebody? Why? Are you Peter Touch? You don't know Peter Touch? The agency. That's why I said, yeah, yeah. What? What's wrong with you? Peter Tosh, back then when Bob Marley was alive, there was a reggae man that reigned even a little bit more popular. But so his name was Peter Tosh. Came from the same place. Yeah, they are both reggae king. No, I just anytime touch comes to my mind. I'm like, I say, are you Peter Touch? His name is Peter Touch, but that concept of touching something, I'll tell somebody like, are you Peter Touch? So, okay. He was. Yeah, if you wanted to.
Wait, that's what she did, like, she did it. She did it, but she under the condition that all of the citizens close all of their doors, all of their windows, everything, right? So then she had her famous naked ride on the horse through the town. Yeah. But then Tom, Tom, he just did like this. So there was security that were watching. Apparently, I read it on Wikipedia. That's apparently how it is. It's either he was stone blind or deaf. One of the two.
Hmm.
But the key way they required the people that olden days someone olden days. The standards were way lower.
Uh, I don't even know what to say again. Oh, I really don't know what to say now.
I know his wife had those. What? Oh, do I say what reasons? His wife had his wife had. Oh, that was okay. Oh. I'm just saying she's brave. She was brave for that. Everything and response.
This could be a crate of whatever this guy is.
Fate of Coca-Cola.
That wasn't cool.
So, no, this is Aqua. It's Pepsi. The PepsiCo owns Aqua. I think this is person.
Pepsi,
PepsiCo.
PepsiCo, Pepsi Company, PepsiCo.
The Coca-Cola and Pepsi. I don't understand.
No,
No, Pepsi was made by the former Coke. So that's